So I think I have a tough spot because you just had pizza, and my main challenge is going to be to make sure you don't fall asleep. And I already see some concerned faces thinking, I hope she knows it's not June, because otherwise it's going to be an interesting conversation. No, but I actually want to take you back a few months to June 12th this year. And I want you to picture this. You're a developer, you're working at Google, and you're living a pretty happy, carefree life. Until you wake up one morning and you find that Gmail is down, Google Meet is down, Spotify, Snapchat, YouTube, Discord, all gone. Why? Oh, that's just a few lines of code you wrote like 3 weeks ago. And maybe you remember this incident, but it was a pretty cool tutorial we got from Google on how to break the internet. Because the details were, long story short, is there was a single line policy change in Google's IAM, and it introduced a null pointer exception. And because of the central nature of Google, it managed to break down about half of the internet. And such a tiny change as well, it was very kind of catastrophic for them. And unfortunately, it was the type of incident that costs millions for Google. Millions in SLA penalties and millions more in lost productivity and trust from their customers. And the scary thing is that if it can happen at Google with world-class infrastructure and automated testing and CI/CD pipelines and Kubernetes clusters humming, then it can probably happen anywhere. And what's interesting to me that this wasn't a DevOps failure because the rollout itself was a technical success. The code got deployed smoothly and consistently across all global regions. The problem was that the team had no runtime control over the feature once it was already in production. And if we look at the rollback story, we get quite an interesting picture. So they actually identified the root cause in 10 minutes. Not bad, I think. They prepared the rollback and they deployed it in 40 minutes. Also pretty good. But the actual incident still lasted for up to 4 hours. And this is because of all the systematic recovery delays and kind of the backlog clearing. So now that's not ideal, is it? And this is because DevOps got the code out fast, but it couldn't bring the system back up fast. And that's because DevOps stops at production. It stops at deployment. It gets your code to production, but it doesn't decide who sees what, when, and how. So we need something else. And in Google's own words, this is actually from the incident report, or the postmortem they had after the incident. They said, oh, if we had just used the feature flag for this, we would have caught it in staging. And going forward, we're going to put most critical things behind feature flags. And so yeah, a bit of a spoiler, but this talk is about FeatureOps, aka feature flags, and how we go from this 3 a.m. firefighting to impact-driven releases. And my name is Melinda. I am a developer, I'm a technical writer, and a little bit about me so you know who you're talking to. I grew up in Hungary and lived a bunch of different places before moving to Bressanone, which you may have heard of it. It's about 2 hours from here, very pretty mountain town, highly recommend it. But I spent a big chunk of my career working in London. And as you can probably tell by now, I'm a huge fan of feature flags. And I first started using them in 2018. And at the time, I was working for a financial services company. And mostly, I worked on these API integrations with big banks. And I probably wrote like 10 different microservices during my time there. And if you've ever worked with microservices, that you know that they can quite easily misbehave. But it was absolutely critical that those services don't go down because, in the financial services domain, even just like a few minutes of downtime is very detrimental for the business. So, of course, we had 24/7 on-call. And after a few very painful, at night on-call shifts, my team decided, okay, we need something in place, and we started using feature flags. And initially, we had like a super basic setup. We used Scala at the time, so it would have looked like something like this. And we were just using these boolean values in config files, very basic. Actually, maybe it's a good time for me to ask, is there anyone here who doesn't know what a feature flag is? Can't tell if you're shy or just an expert, or maybe you don't understand me. Maybe I ask a different way. Who here knows what a feature flag is? Okay, some people, good. So just to recap, it's basically an if statement in your code that checks a condition, and then based on that condition, it decides whether to run the new code path or an old one. And you can also think of it as like a runtime switch that lets you turn a feature on in production without having to do a redeployment. So it's very powerful. And of course, this super basic setup we had back then was, it was still a lot faster and more precise than a full redeployment, but it wasn't perfect. Today, there are a lot of tools out there, open source tools, or some companies decide to do feature flagging in-house, but they allow you to just go into a UI, click a button, and turn a feature on or off. And you can do so without, whether you wrote that piece of code or not, whether you're a developer, product manager, SRE. So it's a very powerful tool. But in my mind, they are so much more than just like simple on or off switches, because they really let us control how your feature gets to production, who sees it, when, how, and how it's rolled back if you ever need to roll it back. So I want to talk about how we go from DevOps to FeatureOps. Because if I want no doubt in my mind that I love DevOps, and I want to be invited in this conference in the future. So otherwise, Martina would be like, if she hates DevOps, she can't come back. I love DevOps. I think it's one of the best things that happened to humanity. It completely revolutionized how we deliver software. And it's pretty much an industry standard now. If you just go back 5, 10 years, maybe some of you are too young to remember, but we used to have these big bang releases, right? Like super risky, not fun for anybody. And life is a lot better now because I assume, hopefully most of you are deploying in smaller, more predictable increments. And we have a lot of industry standards around it, like the DORA metrics. I don't know how many of you are familiar with them, but we can look at a couple of different dimensions, and then they tell us if we're good at DevOps. So one thing we can look at is our lead time for changes, which is how fast can you get an idea from a developer's head or a product manager's head into production. Or you can look at your deployment frequency. How often are you shipping code to your users? Or your change failure rate, like when you ship code, how often do things break? And lastly, your mean time to recovery, which is when you break something, how quickly can you fix it? And we know that teams who do well on these metrics, they also outperform commercially. But now that AI is entering the mix again, or not again, but it's all the hype now, and there's been a lot of talk about AI today, although I didn't understand all of your talks. It seems like it was pretty important. So the DORA metrics, the latest report from DORA tell us that for every 75% of teams who adopt AI, they see a huge improvement in their productivity. And that's not surprising, right? But there's a catch. Because this report also says that for every 25% increase in AI adoption, teams are also seeing a 7.2% drop in delivery stability. And that's scary because it means that teams are going a lot faster now. They're deploying a lot more code, and speed is up, velocity is up, but their reliability, the code reliability, is down. And that's not a good position to be in. And for me, the important part here is that your users, they don't care how fast you ship. They just care whether the stuff that you ship actually works or not. And this is where FeatureOps comes into the picture, because if DevOps defines how your code reaches production, then FeatureOps defines how your functionality becomes available to your users. And that's a very different thing. So if Dora told us a couple of things we can look at to know if we're good at DevOps, how do we know if we're good at FeatureOps? First, are you testing in production? This is a good thing. Trust me, we'll come back to this. Can you disable a single faulty functionality instead of rolling back the entire release? Can you target specific users with a feature or an experiment? Like, can you enable something just for your cousin, for example? And is your release process decoupled from your deployment process? Today, we're going to look at a couple of different companies that are very good at all of the above. So we're going to see some examples of FeatureOps in action and how employing some of these use cases has helped not only change the way they deliver software, but also had an impact on their engineering teams. And we're going to start with Mercadona. Who here has been to Spain or Portugal? Nice. So maybe you recognize it? No? You do? They're one of the largest supermarket chains in Portugal. But yeah, probably you just went to the beach, get it. So they not only have a ton of physical locations, but they also have these online grocery delivery things. It sounds magical to me living in Brixham because we don't have that kind of technology there, but apparently in Spain you can order groceries online and it arrives at your door. Maybe you have that. Anyway, that's just to say that they have a lot of logistical challenges, right? And they implemented gradual rollouts, and we're going to talk about that in a minute. And it changed the way they work now. But to understand gradual rollouts, I want to come back to this thing I mentioned earlier, which is testing in production. Because we all know that if this is your production environment, then this is staging. And that's just to say that there's no way you can replicate all of that real user data, the real use cases, the edge cases that you face in production, and all of that chaos that they introduce in any other environment. So you really need to find a way to be able to test your code in actual production environments. And that's what gradual rollouts and feature flags allow you to do. So instead of just releasing your code to all of your users at once, you start with a small subset of users and enable it for them in production. So in this example, I configured a stage where we enable the feature in production only for our internal users. I used our internal email address for this, but you could use host or IP or user IDs or whatever you want. And then once you're happy, you've tested it, you've dog-fooded the feature, and you're happy with it, then you move on to the next phase, which is maybe 1%, maybe 10% of your users. Maybe you're targeting a specific region. And only when things are looking good, that's when you go to 50 or 100%. And this is what Mercadona did. For some backstory, they have about 1,600 stores. They have millions of online orders and thousands of warehouse workers. So in the early days, when something failed, it wasn't just an app crash for them. It had very physical, real-life consequences because it meant that the warehouse workers were blocked, like physically not able to work, or the trucks were leaving the warehouse late, and their customers not getting their groceries on time. So they had these super big bang risky releases, very manual recovery that was also stressful for the engineering team, and they needed something else. And they started using gradual rollouts, and these are actually the exact names and phases of their rollouts that they use. They start with something called a laboratory rollout. So they have a store, probably Valencia must be, where they enable the feature in production, but only for a small subset of users. And they make sure it's all working correctly. And then they move on to what they call the progressive expansion. And that means that they start training the staff in the warehouses, they measure their KPIs, they validate against all of the things they care about. And only when things are looking good, then they enable region by region, store by store, and end up with their nationwide rollout. And yeah, this was a really massive change for them. Is it just me, or Spain and Portugal look like George Washington? Sorry if you're not ever going to be able to unsee that. Yeah, so instead of doing this firefighting at night, they are now having 4,000 deployments per month with just 13 hours of median lead time. And according to Sergio, who's the head of engineering there, this stuff is nice, but what really made a difference is that their engineers now can innovate without fear of breaking things. And that really is a much nicer environment to work. Next up, I have a story from Wayfair. You might also not know them because they're mostly an American company, but they're one of the largest online retailers there. And I want to talk about instant rollbacks, which is another use case. And another way you might have come across this is kill switches. Sounds scary, but it's actually very fun. So if you compare a kill switch to a traditional rollback, you'll see that it's quite powerful. Again, it's just a feature flag that allows you to click a button and turn a feature off in production if you need to. So instead of rolling back with your CI/CD pipeline, you have an instant rollback. So you go from typically minutes or hours, like we've seen in the Google case, that if a central component is involved, we're likely talking about hours here, to seconds. And you go from an all or nothing kind of approach, because if you're rolling back a release, you're taking everything that was shipped with that release, right? To a very precise and surgical approach where you can just take the one thing that doesn't work and keep everything else as it was working before. And this is, again, the stats from Wayfair. So they have millions of daily shoppers, and they live in this kind of environment where even tiny code changes, like checkout not working or some recommendation algorithm misbehaving, has a huge impact for them. And similar situation as Mercadona, super risky releases, very stressful, full rollbacks relying on CI/CD. And when they started using kill switches, they basically decided, kind of what Google said, that every critical feature should be behind a kill switch. And they managed to find a way that they are tying it to their monitoring and alerting systems as well. So when things go wrong, they can turn something off before even the customers notice. And that's really nice. You don't want your customers telling you that your stuff is broken, right? Third example is from Musician. You may have heard of them if you've ever tried to learn an instrument online, because they're one of the largest music learning apps. And as any kind of subscription-based service, they really like to use experimentation to improve their product. Or A/B testing, you may have heard of. And they face this common tension that many companies who do a lot of experimentation have, is that sometimes when you measure things like clicks in the browser, like does this user end up clicking on try free trial, or some of the conversion events that you care about, those numbers look really good. But when you compare them to the bigger things you care about, like how much money are we making, you can't make that correlation because it's difficult to know what to measure. And what has really helped them is taking in this full stack experimentation approach. And that means not only looking at kind of short-term goals like conversion, but coming up with more wholesome metrics to track. And for example, they track the lifetime value of a customer, which is the total revenue you can expect from a single customer over their entire relationship with you. And this is a custom metric that comes from their data warehouse, and they use it in their feature flags to correlate the data and make sure that whatever they're working on actually increases the lifetime value of a customer. And they measure the impact across several different functions. For example, they look at the voice of the business. In this case, does this change that we're working on improve our lifetime value of our customer? They look at the voice of engineering, which is this change performant? Is it reliable? What about the infrastructure costs? Does it make sense for us to run this? Like, it could be that you're using a new model for an LLM, and it's fantastic, it works really well. But if the costs outweigh how good it just doesn't make sense to run it. And then the voice of the customer. So do our users actually like this stuff? Does it improve our adoption or retention? And at Musician, every new change that they do, whether it's a tweak to the UI or a backend recommendation logic, they wrap that in a feature flag, and they measure against multiple dimensions. And it's really helped them go from chasing these short-term wins to a sustainable growth. Okay, the last example I have is from Unleash, which is where I work. And our engineering team uses feature flags for pretty much everything. But recently, our marketing team started using it as well to improve the experience on our website. And what they found is that when you run an experiment, at a quick glance, it looks like you have a clear winner. So maybe you've rolled out a new design, and your conversion is up by 5%, things are looking amazing, and you're like, let's go, like let's roll this stuff out. But when you dig deeper, you can find that sometimes what happens is that there's a win in conversion data, but it's masking a performance problem. And then we're like, okay, so can we look at some stats to see how bad it is when the performance on your website is not as good as it used to be? So these are stats from Amazon and Google. I forget which is which, but just as little as 100 milliseconds in a latency increase will result in 1% drop in sales. And going from 1 second to 3 seconds in load time means a 32% increase in bounce rate, which is how users coming to your site and leaving without doing anything, which is not great. So we're like, okay, so let's dig in a little bit deeper. And there was one particular experiment where there was one variant that a new design, and it was looking really great. And we just wanted to quickly roll it out, like, this is clearly better, we think it's better. And when we looked at the numbers, we saw that the experiment has added some JavaScript overhead that increased the LCP on the website, the largest contentful paint, which is a performance metric. And that meant that we couldn't trust our experiment anymore because we couldn't separate the positive impact of the new design from the negative impact of the performance problem. So only when you're looking at multiple things at once, you can have a full picture. And in this case, we found that performance isn't separate from conversion. Performance is conversion, and you need to treat them together. And so whenever we now send the conversion events to our analytics platform, we also include, we include which variant the user is seeing, but we also include the performance data along with that. And then, in analytics, we can make a call whether or not overall the change makes sense. And this really comes down to, I think, the key takeaway is that when you do FeatureOps, it really requires the full stack view of impact. So you have to include multiple areas from your business and make decisions together. And of course, I couldn't let you go today without talking about the dark side of feature flags. And the thing is, it's definitely not all like sunshine and rainbows, because when you start using them at scale and you have a lot of them in your code, they can really clutter your code base. So you need to find a way to be disciplined about them and clean them up. And this is a whole other topic on its own, but here are 3 of my favorite tips. So make sure that the reduce, reuse, recycle principle does not apply here. And please make sure you don't end up in this kind of situation. Like having a feature flag that somebody created ages ago, and maybe that person doesn't even work at your company, and nobody dares to touch it because nobody knows what are the different things it controls. Not ideal. So just having a very good process for cleaning up flags is going to get you half of the way. And establishing a flag lifecycle, which is having a clear name, a description, an owner, like when it's expected to be retired, and having a way that you can treat them as like first-class citizens in your development workflow, so that you tie them to the the Jira ticket or Linear or whatever GitHub ticket that created them, and also just make sure that they should have a feature flag should have one purpose and one purpose only, and when that purpose is done, that you clean it up, archive it, delete it from your code, and move on. And don't be tempted to switch it back on for a V2 of that feature or experiment. Just create a new flag. And lastly, name things properly. Like, this is a hard one, of course, but having a good structure around naming conventions and organizations and knowing how and where to evaluate a feature flag in your code is very important. And actually, I've written a few tutorials on organizing flags in code and things like that, so I could send you some resources if you want to dig in deeper. And I want to leave you with this. So I think feature flags aren't just on or off statements. There's so much more than that, because in my mind, they're a living artifact that really tell you a story about your feature, how they go from an idea to production and beyond. And if you start looking at this data, they actually tell you about how your engineering teams are working, and maybe where they are very fast, where they are blocked, and where they need help. And once you start taking in this full life cycle, then you move beyond just like deploying code. You start managing your features, and I think that's how you go from DevOps to FeatureOps.